Hi friends, today we're going to be looking at the examples for the Unit 3 Day 5 homework. This one talks about deciding whether the points in this particular, these two examples, deciding whether or not they're trapezoids. So the only change that you need to make is just this part for A. D is actually this point, and then C is actually this point. So A is at -2, 3. So 1, 2, 3. So right here is A. B is at 3, 3. 1, 2, 3, 1, 2, 3. So B is here. And then C is at 2, -2. 2. So that's C, excuse me. And then D is -1, -2. -1, 2. So there's D. The reason we had to put in that order is because otherwise we would be crisscrossing when we connected these, because we said it's A, B, C, D is the name of the trapezoid. So you got to be careful with that. So let's go ahead and connect these to make our trapezoid, or a quadrilateral. We're going to find out if it's trapezoid. So connect these two here. Connect it across here. I think I have a ruler somewhere here. Probably would do better finding the ruler. I'm trying to use this note card. Use what's handy though. Alright, so there's my trapezoid, or quadrilateral. Maybe it's trapezoid. Let's find out. Alright, so for it to be a trapezoid, going back to our definition, we have to have exactly one pair of parallel sides. So just looking at this, A to B and C to D, these slopes are 0. So the slope of AB is 0, and the slope of CD is 0. So let's see, let's call these segments. So the slopes of them are 0. So if the slopes are 0, then that means they are parallel. Now, a lot of students are just tempted to stop here. The problem is that it's exactly one pair of parallel sides. So I do need to find the slopes of the others. So I need to find the slope of, let's do BC. So if I go down 1, 2, 3, 4, 5, so that's -5, and then to the left one, that's also a negative number. So remember, a negative divided by a negative is a positive. So the slope of BC is 5, 5 over 1, 5. And then the slope of, let's call it AD, so this is going down 1, 2, 3, 4, 5, then right one, so this is -5. Those two numbers are not the same. So because those two aren't the same, they are not parallel. So we have exactly one pair of parallel sides. So this is a trapezoid because I have exactly one pair of parallel sides. So this is a trapezoid. So this is a trapezoid. Is it an isosceles trapezoid? We can do that by finding the distance of B to C and A to D. So if I do, let's see, so if I use the Pythagorean theorem, use that as a shortcut for my distance formula instead of plugging all those numbers in, I could say that the length of AD squared is equal to the length of this side squared plus this side squared. So let's find this. So this side, 1, 2, 3, 4, 5, so that's going to be 5 squared, and that's 1 squared. So that's going to be 25 plus 1, so that's going to be 26. So the length of AD squared is 26. I want to take the square root, so the length of AD is equal to the square root of 26. And I can do the same for the other side as well, from B to C. So the same thing here, so the length of BC squared is equal to 1, 2, 3, 4. That's also 5. 1, that's also 1. So 5 squared plus 1 squared. So you can see this is going to be exactly the same. And that's what we expected to see, 26. So now if I take the square root of both sides, I get the square root of 26 for the length of BC. And so since those two lengths are exactly the same, then I know that these two sides are congruent. So it is not only a trapezoid, it is an isosceles trapezoid. So this quadrilateral, it is an isosceles. Isosceles trapezoid. Sweet. Now number 2. So this one, we've got A is -3, 2. I'm going to switch to a different color just so it's easier to see. -3, 2. So there's A. B is 3, 0. 1, 2, 3. So there's B. C is 4, 3. 1, 2, 3, 4, 3. And then D is -2, 5. 1, 2, 3, 5. There we go. Oh, I didn't go far enough over for A. I'm sorry. Oops. Good thing I'm using an erasable pen. There we go. And then that's D, and then C. There we go. So now when I connect these, right now it's a quadrilateral. So we're going to check to see if it's a trapezoid or not. Now remember, for it to be a trapezoid, it has to have exactly one pair. It has to have exactly one pair as a parallel side. So let's go ahead and find the slope. So let's do the slope of, let's check AB and CD. So the slope of AB, so go down 2 and then right 1, 2, 3, 4, 5, 6. So -2 over 6. So that reduces to -1/3. So the slope of, now I'm going to check CD because that's the opposite. We're checking the opposite side. So the slope of segment CD, segment, it's also going to be down 2, down 2, and then right 6, and then also reduces to -1/3. So these slopes are the same. Now remember, we also need to check the others as well. So I need to check the slope of, let's check BC. So I'm going to go, starting from being 1 to Z, to C, 1, 2, 3, and then to the right 1 is, so that's up 3, so 3 over 1, or 3. And then the slope of segment AD, so up 3 and right 1, 3 over 1, so that's also 3. So this is not a trapezoid because it's not a trapezoid because of these slopes being the same, because they're the same. So this is actually something else, another shape that has, we have 2 congruent parts, same slopes. Now we haven't found out that they're congruent, so not knowing that they're congruent, it doesn't give us, too much, but we do know that the opposite sides are in fact parallel, and so that would give me parallelogram. Time. Yep, we're good. So number 3, find the measure of angle F, measure of angle G, and measure of angle H. So knowing that this is an isosceles trapezoid actually gives us the angle measurement of the one that's opposite of the one that's given. So 110 degrees, we know that this one also has to be 110 degrees. And the reason we know that is because these two have to be exactly the same. So over here off to the side, I'm going to do measure of angle F is equal to measure of angle G is equal to, and the measure of angle H is equal to. So we know the measure of H is equal to 110 degrees. We know those two are the same. The other thing that we know is that these have to combine to be a linear pair because of it being an isosceles trapezoid. So 110 plus whatever this number is, so I'm going to do 110 plus some unknown number, has to be 180. So if I subtract 110 from both sides, I get x equals 70. So this is 70 degrees. And then I know that this one is also 70 degrees. So the measure of angle F is 70 degrees. The measure of angle G is also 70 degrees. Gives me that as well. We're going to use the same idea over here to find these. Notice that these two are the ones that are congruent. So measure of angle F, measure of angle G, and the measure of angle H. So the measure of angle F is 68 degrees. The measure of angle G, I know that these two have to add up to be, call it Y this time, 180 degrees. So now I'm subtracting 68 from both sides. Now if I subtract 68 from both sides, I get Y equals 112. So this is 112 degrees, and this is 112 degrees. 112 degrees, 112 degrees. And then for kites, to find the measurements of kites, we can use we're just finding the measure of angle K. We can actually find it all after we find measure of angle K, but remember the measure of angle K is just the same as this one on the opposite side here. So this one is 88 degrees. This one I can just tell by looking. Now this one is a little bit different because I need to know these two angles are the congruent angles. So it doesn't give me the congruent angles, it gives me the other angle. So I'm going to add up these two. So 60 plus 50, that gives me 110 degrees. Now, the whole entire measurement of all of the interior angles, because it's a four-sided figure, is going to be 360. So if I subtract off the 110, that gives me 250 degrees. Now, that's between both of them. Knowing that they're both equal, I can just divide it by 2. So 250 degrees divided by 2 gives me 125 degrees. So the measure of angle K, which has to be the same as the measure of angle M, is 125 degrees. The last part, on the back here, use the kite theorems and the Pythagorean theorem to find the length sides of the kite. If necessary, round your answer to the nearest tenth. So the Pythagorean theorem is basically using the a squared plus b squared equals c squared to finding the length of each of the sides. So the nice part is that you only have to do this twice. We can do it once for this side, and then it's going to be the same for this side. Same down here for the bottom. So if I find the length of SV, so the length of SV squared is going to be the same as 5 squared plus 5 squared. So SV squared is equal to 25 plus 25. So SV squared is equal to 50. Square root both sides. And I get SV equals square root of 50. Now it says we're rounding the nearest tenth. So I'm going to take the square root of 50 in my calculator. This is why I should always have my calculator ready before I start recording. I never have it ready before I start recording. There we go. Oh no. I know it's going to be really close to 7. I know that because the square root of 49 is 7. Square root of 50 is, so it's approximately, oh, I should use the approximately symbol here since we're rounding at this point. Approximately 7.1. Now because it's the same on the other side, I know that ST is approximately 7.1. Now we do something similar to find the lengths of the bottoms. So I have UV squared is equal to 5 squared plus 12 squared. 5 squared is still 25, and then 12 squared is 144. That's going to give me 169. So UV squared. And then the square root of both sides gives me UV. This one's exactly 13. So I have 13, 13, 7.1, 7.1. So I found all the side lengths of the kite using the Pythagorean theorem. Doing the same for number 9. So this one, 8, 9, 9, and 7. So we have these two here are going to be the same, and then these two here are going to be the same. So let's do ST this time. So ST squared is equal to 8 squared plus 9 squared. So 8 squared is 64, 9 squared is 81. So that's going to be 64 plus 81 is 145. So the square root of 145. So ST is approximately 12.0. So that's here and here. 12.0. Then we do the same for the bottom. So let's do TU squared is equal to 9 squared plus 7 squared. 9 squared is 81. 7 squared is 49. What is that? 130? There we go. I almost said the wrong thing. Square root both sides. The square root of 130 is, so TU is approximately 11.4. So that side and that side are 11.4. And there you go. Have a wonderful day.